These are all true-false questions related to the concept of subset. And before we can do anything, we need to remind ourselves about what a subset is. The symbol for subset is a sideways U with an underline, and a set A is by definition a subset of the set B if every element of A is also an element of B. In other words, if you think of the set on the left as set A, and the set on the right is the set B, then every element in A has to also appear in B. So there's apple in A, there's apple in B. There's pear in A, there's pear in B. There's peach in A, and there's peach in B. So by definition, the set containing apple, pear, and peach is a subset of the set containing apple, pear, peach, and orange. So that first statement is true. Notice that the symbol in the second example is different than the symbol in the first example. There's no underline. That symbol is for something, a related concept called a proper subset. So we have to change definitions. The symbol for proper subset is a sideways U with no underline. And a set A is a proper subset of the set B if every element of A is also an element of B. That's the same thing as before, but with the added condition that A and B can't be equal. In other words, they can't be exactly the same set. But otherwise the condition is the same. So you start off the same, you're looking, you see apple on the left, apple on the right. Pear on the left, pear on the right. Peach on the left, peach on the right. So every element of A is also an element of B. And it's also true that they're not equal because orange is in the one on the right, the B, but not in A. So they're not equal, and yet the other condition is satisfied. So that's also a true statement. The third example goes back to the subset. So I have to switch definitions again. But you have to be careful about these little things, they matter. So now I'm saying subset. This set on the left, which we're calling A, is a subset of the set on the right if every element of A is also an element of B. So you look again, apple on the left, apple on the right. Pear on the left, pear on the right. Peach on the left, peach on the right. So every element of A is also an element of B. So that's a true statement. Now notice something else, that they're also equal sets. A and B are actually equal. But there's nothing in the definition of a subset that says that A and B can't be equal to each other. So even though they are equal, the other part of the definition itself is actually satisfied. So that statement is true. I want to contrast that with this last example, which goes back to the proper subset definition. Notice the set on the left, the A is the same as the one above, and the set B is the same as the one above. But the symbol is different. Now I'm asking about a proper subset. So now in addition to every element of A being an element of B, I also have to look to make sure the sets aren't equal to each other. So even though apples on the left and apples on the right, pears on the left, pears on the right, peaches on the left, peaches on the right, this is still a false statement because the second part is not satisfied. A is not supposed to be equal to B with a proper subset. So this is actually false. So noticing the difference between these two is extremely important. It's almost like the concept of less than and equal to when you're talking about inequalities. 5 is less than or equal to 5, but 5 is not less than 5. It's sort of that same sense.